Section 1.1, example 1.6, finding lower and upper sums for f of x is equal to sine x. Ooh, trig functions. So find the lower sum for f of x is equal to sine x over the interval ab, which ends up being 0 to pi halves. Let n equal 6. Ooh, that one's fun. All right, just like I did with the previous two, let me draw the graph and then I'll be right back. I'm back. All right, so find a lower sum for this. What I wanted to do is actually show you guys how we could draw these, because it does seem a little ugly. Let's figure out what our delta x is, our change in x. So delta x is equal to b minus a, so pi halves minus 0 over n over 6. All right, that's going to be our pi over 2 over 6, which is our pi over 12. So we're moving pi 12s with each of these. So pi over 12 with each of those. So starting off at 0, we're moving pi 12s to the left. Let me just partition this really quick. I just picked like what I felt was like the middle point between those two and adding 2 more equally in there. So should have a total of 7. 1, 2, 3, 4, 5, 6, 7. The professor thought n was equal to 6. Well, n is equal to 6. If you notice, even in a square, one square, we have 1, 2 sides. If we're looking at 2 squares, we have 1, 2, 3 sides. It's always one more than what n is. So that's why it would be 7 in this case. And now looking at this first one, we're moving pi 12ths here. So pi over 12 there. And adding another pi 12s, that's 2 pi 12s, which is pi over 6. All right, next one is going to be 3 pi 12s, which reduces to pi over 4. Next one is 4 pi 12s, which is pi thirds. So for 5 pi 12s, doesn't reduce. And just to test our skills, next one is our 6 pi 12s, which is just pi over 2. Oh my goodness, we got it correct. All right, perfect. So we got that. Let's erase our work over here. Now that we have our space partitioned, let's look to see where our graphs are going to be. I'll bring this all the way up here. I'd like to take this time to add that I am not an artist. We're all doing our best here. I know I do have technology on my side, but time isn't on my side either. All right, so we have our stuff broken up here, and let's get a recap of what they want us to do. Find the lower sum. All right. Okay, well, not bad because our lower sum, like at this point, it's still lower. Okay, so it's going to be lower on the left side, lower on the left side here, lower on the left side here. And the only time that it would be lower on the right side is going to be on this part of the graph. So we're just going to use that left all the way through here. So lower is left. Let me see how I did over here. Lower sum right end. So let's put a little asterisk. Lower sum for this problem is going to be the right, I'm sorry, left end. So notice that it was backwards in the last one. Lower sum was the right on the other one. Lower sum is the left here. All right. I feel like at this point we're kind of experts, so we don't really need everything. So we could kind of just start from here. So L6 or our area is approximately our lower 6 squares. And we'll factor out, because each of these have that pi 12s that we're multiplying, that's our width for each of those. And let's get, actually, we have a couple more here. I'm afraid that I might run out of room. So let's move this over this way. All right, so lower, we're using the left side. So we're using f of 0, f of pi 12s, f of pi 6, f of pi 4ths, f of pi 3rds, and last one, f of 5 pi over 12. All right, what was our function? Ooh, our function was just sine of x. So sine of 0 plus sine of pi 12s plus sine of pi 6 plus sine of pi over 4, sine of pi 3rds, and lastly, sine of 5 pi over 12. I hope you guys refreshed on your truths. All right, so sine of 0 is 0. With a little bit of manipulation and fun, sine of pi 12s is a square root 6 minus square root 2 over 4. This one's one we're familiar with, pi over 6, that's 1/2. Pi over 4, that's root 2 over 2. Sine of pi 3rds, that's root 3 over 2. And a little more fun, root 6 plus root 2 over 4. It's brackets. All right, so for these, if you guys want another video on this one, please let me know. What were they? But I use like the sum and difference formulas for sine. It was fun. I kind of feel like a little nerd right now. All right, so adding everything together, what I'm not crazy about is having these denominators of 2. So I'm going to make them denominators of 4. So that one disappears. We still have that root 6 minus root 2 over 4. That's 2 over 4, 2 root 2 over 4, 2 root 3 over 4, root 6 plus root 2 over 4. Let me be a little lazy again. Let's factor out that 1/4. So now we have root 6 minus root 2 plus 2 plus 2 root 2, 2 root 3, root 6 plus root 2. All right, those two simplify. Oh, pi over, what is that, 48? And we have, let's start with the root 6s. We have 2 root 6s. Root 3s, we have 2 root 3s. Root 2s, we have 2 root 2s. And whole numbers, just 2. All right, let's see from here. We're able to simplify these a little tiny bit. So each of these have a 2. We could factor out that 2. And that gives us 24 here. So we have pi over 24 times root 6 plus root 3 plus root 2 plus 1. All right, let's plug that into our calculator and see what we get. Oh, that's convenient. Okay, so pi over 24, and we're multiplying that with the square root of 6 plus the square root of 3 plus the square root of 2 plus 1. All right, 0.86338. I'm just going to say 8634. And there we go. Perfect. And that's the lower sum of sine x for this interval. If you happen to have any questions, please do not hesitate to ask. Otherwise, bye.